This set of slides will go over the distribution and availability of water around our globe. Of course, if you've traveled around on Earth to different areas, you know that some areas are abundant in water and other areas don't have very much water. And so we can kind of divide these parts of Earth into the arid regions and tropical regions. And then there's also regions that are deserts but aren't warm. So for example, on Antarctica, there is an area that doesn't get any precipitation, but it's cold all the time. So there are deserts that are cold. So if we're just going to compare two dominant types of regions on Earth. An arid region would be somewhere like Phoenix, Arizona, or the Sahara Desert. So this is an area that receives little precipitation and tends to have high evaporation rates because it's warm. So as a case study, Phoenix, Arizona receives about 20 centimeters of precipitation per year. So if you put that into inches, I think that's about 8 inches. And then the main water source for Arizona and for Phoenix is the Colorado River. But the Colorado River is a very impacted river, and very little of the water that is in the Colorado River, if any, reaches the ocean. So most of that water is consumed before it can get to the ocean. And that's because we withdraw the water. The cities are using it, so municipal uses, so people use it to drink and water lawns. And agriculture uses that water to grow crops. Another reason that this water doesn't reach the ocean is because there's very high evaporation rates. The temperatures are high and the humidity is low, and so a lot of water evaporates from this river. If we contrast that with the Amazon River, so the Amazon exists in a tropical region, and the country of Colombia receives, so the Amazon River travels from Colombia and then all the way out over to Brazil. And so the Colombia receives so much more precipitation. They receive about 3 meters or 300 centimeters, so 15 times the amount of precipitation as Phoenix, Arizona every year. And much of the water that falls and runs off into the Amazon River reaches the ocean, and that's because there are less withdrawals coming off of that river for farming and municipal use, although that is increasing. And then there is less evaporation because the air there is humid, and so there's less driving force of putting moisture into the warm air. So just to highlight even on a larger scale the differences in precipitation around the globe, we can look at this map of all the land surfaces on Earth. And if you look at this map, you can see areas of brown and red, and that's contrasted with areas of blue and green. So the brown areas tend to be in our upper latitudes and lower latitudes. These are the subtropics. And then the green and blue areas tend to fall in the middle latitudes, which are the tropics. And so the tropics receive the most amount of rainfall, and then the subtropic regions receive less. So why is this? We've talked about this in previous lessons. There's many factors, but some of them include global convection currents, rain shadow effect, and then other geographical factors that affect how much precipitation different parts of the globe receive. And then, of course, not all of this precipitation gets to the ocean. Some of it is consumed or evaporates. And so this is another map that shows how much of the precipitation that falls on a region reaches the ocean. And this kind of reinforces the previous map. So in the tropical regions where there's a lot of rainfall, most of that actually gets to the ocean. And there's high levels of annual water runoff getting to the ocean. And then in these areas where we saw less precipitation, most of that gets consumed before it actually gets to the ocean. Right, so we know that there's different forms of water on Earth, and so we will look at kind of the different amounts of water that exists on different continents based on the type of water. So of fresh water, most fresh water exists in glaciers and ice caps, about 67 to 70%. So if we look at this first map, purple map, that's showing the amount of water that exists in glaciers and ice caps on each continent. And so each ball here in the map represents the amount of water that exists in that form on that continent. And so the balls, for Antarctica and Greenland are of course huge. That's where most of our glaciers and ice caps are. But North America also has a fairly large ball, and Asia has a fairly large ball. So we have tall mountains and some northern areas that have glaciers that exist year-round. Well, glaciers exist year-round, but also ice that exists year-round. In the bottom map, we're looking at groundwater. These balls are also very large because about 30% of all fresh water on Earth exists as groundwater. All countries and all continents have fairly large supplies of groundwater. And so this is a resource that exists for virtually all continents to use. The downside of groundwater is, of course, you have to extract it in order to use it. When we look at surface water, the balls for each continent are much smaller, so there's much less surface water available on each continent, and some of the balls are so small that we can't even see them on this map. So South America and Australia have very low amounts of surface water compared to the amounts of groundwater that we saw. So the Asia and North America tend to have the most surface water, but these are also fairly large. Oh, I'm sorry, in Africa. But of course these are very large land masses compared to some of the others. But still, all of these balls, you'll notice, are much, much smaller than the amounts of water we saw for groundwater and even for glaciers in some cases. Okay, now in this graph or map that we're looking at, this is merging information about population of different regions and the amount of water that's available in terms of fresh water for each continent and even countries. So this has lines that delineate countries. And so you can see that areas that, there are some areas that are not as low in water, however they have high populations, and so then that limits the amount of water they have available per person. So this graph is showing freshwater availability in cubic meters per person per year. And so while we did not see that some of Asia was low in water overall in terms of fresh water, we do see that if you look at the amount of fresh water available per person, we do see water scarcity issues encroaching because the populations are high. And the same for parts of Europe. We have high populations, and so even though we have a fair amount of water, we don't have enough per person. We see that also in the Caribbean, high populations for the amount of water that we have. That leads us then to discuss water scarcity and the definition of water scarcity. The United Nations defines water scarcity as the annual water supply. And if an area has water scarcity, then the annual water supply is less than 1,000 cubic meters of water per person each year. Right now, about half of all people in the world live in areas that experience water scarcity, and they're saying for at least 1 month a year. So at least 1 month a year, the amount of water that's available per person is too low, and it's not meeting the needs of the people. We expect that the percent of people experiencing water scarcity will increase in the future as the climate changes, and that will cause many more people to be displaced. Asia is home to about 73% of all people that are experiencing water scarcity. And so again, this is uh, partially due to low amounts of surface water, but mostly it's because of the high population. So the amount of people compared to the amount of surface water is low.